Ang uban.
Wala, ma'am.
Wala sa dun.
Alright, it's okay. So, we have... Okay, so we are in chapter 6. Manibalik na, no? But, muadto ta sa chapter 20 naman na ito after this one. So, mukha sa tagamayan ni chapter 6. So, we have thermochemistry, energy flow, and chemical change. So, we have enthalpy, we have stoichiometry, Hess's law, and standard enthalpies of reaction. Okay, so we have thermodynamics is the study of energy and transformations, while we have thermochemistry is a branch of thermodynamics that deals with heat involved in chemical and then in physical changes. So, katong ni Agi, we've already talked about endothermic and exothermic reactions, so that's part of thermochemistry. So when energy is transferred from one object to another, it appears as work and heat. So the first law of thermodynamics is that no energy is not created nor destroyed. So the amount of energy, okay. Now if we have this one, if we have a system, now there's okay, so we have the first law of thermodynamics that states that energy cannot be created nor destroyed. Okay, so we are very familiar with that. Or it can be, it's not created, but it's not the, unless you are God, so no ka, you can create energy. But the energy present here in the universe is equal. Now, it cannot be created nor be destroyed. Now, if the universe is given with 100 joules of energy, joules is the unit of energy. Example no, gamay ra kaayo. So, example lang. Now, the if we are given with 100 joules, then that 100 joules will be where is circulate na siya, will be transformed into another form of energy, but di na siya mawala. 100%, 100 joules or Japan siya because that's the law. That's the first law of thermodynamics that energy cannot be created nor be destroyed, but it can be transformed from one place to another. Okay, so let's say if we have, okay, so if we have this circle, okay, this circle is what we call our system. Okay, so if we have that system, and then inside the circle, we have a solution. So, example ha, sa flask. Okay, you have a solution. Now, the solution there is your system. Now, outside, everything that's not part of the system is what we call our surroundings. So we have that one. Now, energy can flow in two ways. It can be in the form of, okay, we have energy can flow in two ways, which is in the form of heat or work. So we have your, okay, if we add heat to the system, or Q, heat is, our symbol sa heat is Q, and then we will add work to the system. So the energy, the total energy present in your system is the amount of heat that we add to the system plus the amount of work we add to the system. That's the total energy. So we have this formula, or that is energy is total energy, total internal energy. Other books they write as delta U. Okay, so don't be confused. That's still internal energy, but here let's use delta E. Delta E is equal to Q plus work. Okay. So now we know, but what if the surrounding, okay, what if, so this is your surrounding. Now, if we will add 300 joules, okay, 300 joules of heat to the system, what will happen to the internal energy? What will happen to the energy of the system? Total energy of the system.
Increase mo.
It will,
Increase.
okay, so internal energy of the system will increase by 300 joules of heat. Now, what will happen to the surrounding?
Makuhaan.
Okay, now the system will also decrease po siya by 300 joules. So it's the same whenever the system gain, the surrounding lose. So meron siya, ano ba, merong money. Now if for other person to gain money, now he has to transact or bumaligya siya. Now the other person who will buy kato yung product, then the person will lose money while the seller will gain money. So it the same amount, okay, the same amount of money that the seller will gain and the same amount that the buyer will lose. So that's why here we also it goes like that. Whenever the system has increased 300 joules of energy, then the surrounding has lost 300 joules of energy. So because, okay, that's the first law of thermodynamic. Okay, so that's the first law. Energy is not created, energy cannot be created nor destroyed, but it can simply be transformed from one place, so from the surrounding to the system, or from the system to the surrounding. So we have that one. Now, whenever, okay, so that's why we have the sign of positive. Now, whenever the system absorbs, okay, absorbs more, gain energy, then it will increase. So it has the sign of positive. Now, okay, if the system releases heat, so Q will be Q will be negative. Okay, so whenever we release heat, then Q is negative. Now, whenever we absorb, Q is positive. Now, for work, we have that one. Heat is released. Whenever we have negative, heat is absorbed. Absorbed. Now, so negative and positive refers to the direction of heat. So for work, we have, if the work, okay, okay, if we add work to the system, what will happen to the energy?
Madungagan, ma'am.
Okay, so madugangan siya. What will happen to the system? So the system's internal energy will increase if the work is done by the surrounding to the system. So it will increase when the work is done by the surrounding. So if ano lang ako ni undergrad ko ni is ako siya i-relate na when someone does the work for you, 'di ba? Di ka makuha ng energy but madugang ka doon ka, madugangan na nakag-output at the same time, your energy plus the energy of the other person will be add up to you because you will you will have more output. So whenever someone does the work for you, then you will gain. Now, so that's the system. Now, if the system itself does the work to have an output, then it will have a negative sign or work is negative when the system does the work. Okay. Or work done by the system. Okay, we have that one. Now, kung ikaw may magbuhat sa work, then your energy will decrease. Nana siya. Okay, we have that one. Now, let's go. Now, going back, what should we do to increase the internal energy of the system? Emma.
Magkuan. Mag-add ka og unsa to kong question ma'am, balik ka daw. Char.
What will we do so that the internal energy of the system will increase?
Kung mag-add ka og kanang dako nga amount sa joules or kuan,
Masa nga chose?
sa heat ma'am kung
Heat.
example,
Hmm? Example?
pero sa to imong giingon ma'am kung nag-add ka og 300 joules nya kung mas dako man siya ma'am, so mas ma-increase ang iyahang kuan kanang
Okay. All right. So, in order to increase the internal energy of the system, we will add more heat and then we will, or the surrounding will do the work for the system. Okay. Not the system will do the work. So, that is to increase the internal heat energy of the system. Now, whenever we have a flask, okay, so we have HCl here. All right, now if we have HCl and then water, okay, so this is a solution. Now, the solution, that is your system. Now, the flask, and unsa pa siya, naka sa inyong balay, kusina ninyo, or naka sa laboratory, the laboratory, that is the surrounding. Okay, so we have that one. Now let's. So the system in this case, okay. So we have here. So we have, if we have this solution, okay, the system in this case is the contents of the reaction flask. Now the surroundings comprise everything else, including the flask itself. So the flask itself is part of the surrounding. Now the system is only the contents, katurang sulod or imong solution. That's the system. Now, why do we need Ganun kinahanglan man na there's an exchange of energy from the system and then to the surrounding or vice versa. Ano kinahanglan man? Ma'am, ug dara na lang na siya, ma'am. Sa system na na siyang energy ha, ma'am. Di na mo hilabot ang surrounding or sa surrounding na lang na, ma'am. Di na ibutang sa system.
Need man ang heat, ma'am, para mo transform ang solution.
Right. We need heat. Alright. So that main reason is because for us to achieve equilibrium. Equilibrium, di ba? Balance. So we need to be balanced with the system and then the surrounding. And it's in giving and then taking, giving and taking. So the surrounding and system exchanges energy for us to attain equilibrium. Okay, and also for us to convert other forms of energy like light, heat. Okay, we have that one in order for us to para naatay work would mabuhat. Okay, we have that one. So that's why they exchanges heat and then also the work to achieve equilibrium. Okay, so we have that one. Now, okay, so a meaningful study, okay, system plus surroundings. Okay, so we have the system and then we have the surroundings. A meaningful study transfers energy that we first clearly define both the system and then the surrounding. We have this one, the system plus the surrounding. That's the universe. Okay, so if if this is your inside is your system, okay, system, then outside is what we call surrounding. Now, if i-add mo na sila tanan system and then the surrounding, we call that universe. Then the internal energy of the system is the sum of the potential and the kinetic energies of all the particles present. Then the total energy of the universe, okay, this one, okay, the total energy of the universe remains constant. Okay. Now, kinsa man naghatag sa energy? Okay. Do we create energy? Wait, sa class ha. Charge. Hello. How are you? Good. Hello. Hello.
Yes, ma'am. Madugtong ka, ma'am.
Okay. All right. So we have that one. The total energy of the universe remains constant. So energy, so this one supports the idea that energy cannot be created nor be destroyed. So the amount of energy is equal, just that energy can be transferred from one place to another system and that one. A change in the energy of the system must be accompanied by equal, okay, this one, equal and then opposite change in energy of the surrounding. That's why the same amount is gained and the same amount is lost. Next. So we have this one, the final, this one. So two cases where energy is transferred as heat only. So the system, okay, so this is the initial. So the system releases heat. Okay, so if the system releases heat, so Q is less than zero. So from this one, from hot, okay, from hot, init ka siya, and then it releases heat to the surroundings. So now it became room temperature kay nakuha ni mga heat. Then because it also release, so it will decrease. Heat will be less than zero. Now this one also, if the system does the work, okay, if the system does the work, then W will be negative or W will be less than zero. The system does work on the surrounding. So the system has work done on it by the surrounding. Okay, if the system does the if the surrounding does the work, then work is positive. Okay, so we have the sign conventions for W, for Q, W, and then you have your E. So positive Q means system gains heat, then also negative means system releases heat. For W, we have work done on the system, then work done by the system. Okay, so if we have both positive, if we have now, mo na ito ginabuhat, diba, to increase the internal energy of the system, we have to add heat and then we will do the work. The surrounding must do the work. So to have a positive and then to have a higher amount of internal energy. Now, if we have positive, if the system absorbs heat and then the system does the work also. Now that depends on the sizes of Q and W. That depends if what will happen to your internal energy will depend to the one who has higher amount. Okay. We have also this one, if we have both, if we have different signs, negative and then we have positive, also that depends to the sizes, to the amount of your Q and W. Then we have, if we have both or negative, then your system will decrease internal energy. Okay, let's solve problem. So we have first law of thermodynamics states that the total energy of the universe is constant. So energy is conserved and is neither created nor destroyed. energy is transferred in the form of heat or work. Now we have that one. So why is it zero if it is constant? Ano na zero man siya? Because, for
Wala pa na
example, ah,
wala pa ma-identify ang iyang kuno, ang iyang value or
okay. Mo na yung value ano, Ariel. So we have that one because again, diba? They will gain and they will lose. It will gain 100 and then the surrounding will lose 100 joules. So 100 positive plus negative, then that will be zero. Because again, it's zero because the same amount of energy will be absorbed or released by the system to the surrounding. So we have this one here. Okay, a change in internal of energy of the system must be accompanied by equal and then an opposite because what amount of energy you release must be the same amount of energy be absorbed. So equal and then an opposite. So if we have an opposite, so then it will become zero. Okay, so we have also so we have units of energy. So the is SI unit of energy is joule, just like your concentration. The SI unit of that is molar. So your for energy we have joules. Now 1 joule again, 1 joule is equal to 1 kilogram meter square per second square. Or in physics, we have times Newton because kilogram meter per second square is equal to Newton. Now Newton times meter, then that will be joules. Or we have this one na lang. Then for the we also have another unit of energy. We have calorie. So it was once defined as quantity of energy needed to raise temperature of 1 gram of water by 1 degree Celsius. So later we will answer this one. So 1 calorie is equal to 4.184 joules. So you will just convert. Now also in 1 kilojoules, how many joules?
1,000, ma'am.
Okay, 1,000 kilo, di ba? Kilo. In 1 gram, in 1 kilo, how many grams?
1,000. Ay,
1,000.
lagi 1,000.
Okay, we have also 1,000. Okay, 1 kilocalorie, how many calories?
1,000, ma'am.
Okay, we have that one. So just don't forget that 1 calorie is 4.184 joules. Okay, so let's have this problem. Now, when gasoline burns in a car engine, the heat, okay, please read. Please read. Angelina. Angelina. Okay, please read the no problem. Okay.
ma'am.
Yes, ikaw, Angelina.
Problem. When gasoline fumes in a car engine, the heat release causes the products CO2 and H2O to expand, which pushes the pistons outward. Excess heat is removed by the car's radiator. If the expanding gases do 451 joules of work on the pistons and the system releases 325 joules to the surroundings as heat, calculate the change in energy in in joules, kJ, and kilocalorie.
Calories. Okay, so we are asked what is asked. Okay,
Calculate the
what is
change in
asked?
energy.
Okay, the total internal energy. Okay, the change in energy is equal to creative formula. So we have our formula is
Concentration of E plus
heat
Q plus W.
work. Okay, Q plus W. So that's not concentration, huh? Okay, we have that one. Q plus W. Okay, so now what is Q? If the expanding, so again, right, so we burn uh, gasoline burns in a car engine, so the heat releases cause the products we have CO2 and H2O because this is combustion. Now combustion reaction has always the product of carbon dioxide and then we have H2O because combustion is for organic substances. So we have so we will form CO2 and then for H2O. Okay. So then it will expand. Yes. So if we have the piston, let's go back. Now, okay, if we have that one. Now, if we have the piston, okay, kanina piston. Now, the CO2 and then the H2O, okay, so they will move and it will do the work to expand and then to release the heat. Okay. So, we have here. So, ina nang mahitabo niya. Now, it will do the work. Okay. So we have Q. What is Q? Q is released. The system releases 325 joules. So we have Q is positive or negative?
Negative.
Negative, ma'am.
Kay nag-release man
Okay,
siya.
because it released. So we have negative joules plus total of the
325.
work. If the expanding gases do 451 joules of work on the piston. Okay, so what is that? So the
Positive.
gases, also ang gases, is it the surrounding or the system? The CO2 and
The sys-
H2O.
Surrounding,
the,
ma'am.
The uh, the the
the
system.
The
system.
Surrounding.
surround.
Okay, it's
The system.
so the gases is the system. Now it says that the it work on the piston. So what is work?
Work is done by the system.
By the system. Okay, now. So we have
May mo siyang
times the
negative.
sum. Negative.
451.
Okay. So we have internal energy is internal energy ko
Negative
lang.
776 joule. Negative
Negative.
776 joule.
Okay, so we have negative 700, negative 776. So meaning this is the amount of energy that the system has released to the surrounding in order to have, or in order for the engine to work, in order for the car to move. So parmudaga na siya. So it will release negative 776 joules. Now, so we have that one. Calculate the change in energy in kilojoules. What about in kilojoules?
I-convert nato si joules into kilojoule, ma'am, ang value ni energy.
Okay, so we have energy. I do 776 joules
0.776.
times. Okay, we multiply that to 1. Now, in 1,000 joules, we have
1 kilojoule.
joules cancel. So we will be left with kilojoules pila siya. Point.
Negative
0.776.
negative
Negative 0.776.
Kilojoules. What about kilocalories?
negative 0.185.
Uy. Kilocalories.
I-convert si kilojoule to
So
kilocalories.
kilojoules times, okay. Now, in, let's go back to the units. Okay, so now we have, in 1 calorie, we have 4.184 joules. Okay, so go back. We have that one. So negative 776 joules, that is joules, times in 4.184, in 1 joule, sorry. So we have, pilaga ito conversion?
4,181. 1 kilojoule is equal to 4,184 kilocal.
All right, so kidiretso na nimo. Okay, so let's joule sa ta dapat. Okay, joule sa ha. Para makita lang. Right. So in one joule, in 4.184 to no, 4 calories, hi, joules.
Excuse me, ma'am.
We have joules, joules is equal to 1 calories. So we have pila siya. Now, in 1 calorie, in 1,000 calorie, we have 1 kilocalories. Okay, so we will be left with kilocalories. So joules, cancel. Pila ni siya? Negative 776 times 1 divided by 4.184 times 1000. So that is negative 0.185 kilocalories. Okay, so this will be your answer. Question.
None, ma'am.
Okay, all right. So now that I'll show you, identify who does the work, and then identify also if heat is released or if it is absorbed. Okay, now we have enthalpy, so chemical change at constant pressure. Now, if we have at constant pressure, then that is what we call enthalpy. Enthalpy is defined as E plus PV. So, because work, so because where pressure is constant here, so chemical that is enthalpy. Now internal energy, we have this one. Energy is equal to Q plus W. Now also we have another formula that work is equal to negative P delta V. So the work done when the volume of the system changes in the presence of an external pressure. Now when we have ano now when we are going to calculate energy when involving the volume, meaning that it has expanded or the gases has expanded or has compressed, then you can use this formula. Then enthalpy also is defined as E plus PV. So delta H is equal to energy plus delta PV. Because we also have this formula, E is equal to Q minus P delta. Okay, we have that one. If the system remains at constant pressure and its volume does not change much, then we have delta delta H, or the enthalpy, is just equal to your energy. Okay, so let's solve problem. So we have this one, the system. So the gases here can compress, meaning that from 3 liters to 1 liter. So it has compressed. Now, if it has compressed, then we will have work is equal to positive or negative. So work will be positive if it has compressed. Okay, we have now. Let's solve problem. Actual problem. Okay, can you solve? All right, this one. In each of the following cases, determine the sign of delta H. State whether the reaction is exothermic or endothermic, and draw the enthalpy diagram. Okay, so I'll give you an example here. Ito ganina. Okay, so if we have delta E plus is equal to Q, then the formula is plus W. So if you are given, if it says that the system has absorbed 3,500 joules, and then at the so the gases expand. So if the gas expands from 3 liters to 6 liters. So this one is your V1, and then we have your V2, the volume. Okay, the volume of your gas has expanded from 3 liters to 6 liters. Then that is at pressure at 5 atm. Okay, the unit of pressure is atmosphere. Okay, so what is internal energy, or the change of energy? Change of energy is, again, it absorbs. So we have Q plus W. Now we know, okay, so what is Q here? Q is,
1,500 joule.
8,500 joule.
okay, it's positive because it has absorbed. Then what about W? Okay. Now we also have the formula W is equal to negative P delta V. So we have negative. What is P? That's pressure. So what's the value of your P?
5 atmospheric pressure mo.
Okay, that's 5 atm times, what is delta V? Now delta V is, okay,
3
delta
liters.
3. 6 minus, okay, V2 minus V1. So we have 3 liters. So work is equal to pila, negative 15.
Negative 15 atm liters.
Okay, we have that 1 or liter atmosphere. So that is your work. Now, i-plug na nato siya diri. Okay, but we have to convert atm to liter first so that it will be uniform to joules. Now, we have 101.3 joules. Okay, we have this conversion, 101.3 joules is equal to 1 liter atmosphere. We have this conversion. You have this conversion. So we will convert atm. Okay, di na to siya butang. Okay, so we will convert. We have negative 15 atm liter or liter atm times, we will convert. We have 1 liter atmosphere is equal to 101.3 joules. So that is cancel, cancel. Pila na siya. So work is equal to ilang work? Work is equal to 15, negative 15 times 101 point. We have pila? 15 liter atmosphere times 101.3 joules.
Fifteen na,
One
ma'am, no?
thousand 519.5, ma'am.
Okay, so 1,500. Ay, oh God. 1,519.5
Yes, ma'am.
joules. Okay, so now we will add that one here. So 1,519.5 joules. So internal energy is equal to now.
Dilution negative, ma'am.
Okay, yes, it's negative. So it's negative. Now, di ba, the volume has expanded. So may expand siya from 3 liter to 6 liters. So it has expanded. Now, if it has expanded, meaning this one, then it has a negative sign, meaning the system has done the work for it to expand. Okay. The system has done the work for it to expand. Okay, if we have a piston, okay, if we have a box here, diba, a box here, and now if ano siya, from here, 3 liters, then it has expanded, so we have, may mo na siyang 6 liters. So, the piston, di ba ang piston, mura ka ng ano ba, sa mason, kung magkuan tatrabaho sa balay, na amo na i-down gali na siya para ang yuta makuan jud ma-compact piston. Now, okay, so if ang piston area is here, wait a minute. Okay, if we have a piston, so ano siya, no? I-push niya. Okay, push. Alright, push. Now, because it has expanded, so okay, the system or the gases inside will do the work para ang piston, okay, the piston is move upward. Okay. So, that's why it has expanded. So, mahimo siya 6 liters. So if it has expanded, then the system does the work. Okay, basta simple lang. Inato siya, no, basta nakuha ninyo ni nga. This one, compactor, imagine na lang sa inyong balay, magpabuhat mong balay, okay, naana siya, kuan ang yuta para ma-compact ang yuta. So that's the piston. Now, if the system, the gases inside will expand, then it will do the work for the piston to be moved upward. If i-compress na po nato, if i-compress, then the surrounding, or which is the piston, has do the work for it to be compressed. So the work will be positive. Now, going back here, okay, so going back here, that's why work is negative. Work is equal to negative 1,519.5 joules. So energy is equal to, kani daw class? Negative. Okay, so we have 1980.5 joules. Okay, so it means that the system has absorbed this amount of heat for the volume of the gases to expand. We have that one. So the system thus has absorbed this amount of it. We have 1980.5 joules. Okay. Now, in each of the following cases, determine the sign of delta H. State whether the reaction is exothermic or endothermic, and draw an enthalpy diagram. Okay, we have letter A. Now, letter A, is it endothermic or exothermic? Naanali itong last na to.
Ma'am?
Letter A. Is it endo or exo? Now, if enthalpy, right, we have enthalpy delta H is equal to, what's the formula again? It's, hmm, okay, so we have this one delta H is equal to delta E plus the work. Alright. Now we have that one H2, if we have this gases, hydrogen and then oxygen, so it forms liquid water. So in this reaction, is it endothermic or exothermic? To determine if it's endothermic or exothermic reaction, notice the heat.
Exothermic, ma'am.
Exo ma'am kay
Okay,
nagpagawas og
all right. So heat is
Heat
in
is a
the
product.
product. All right, so that is exothermic. Now, if it's exothermic, delta H is less than 0. Okay, and letter B, 40.7 kilojoules plus the near water,
It's
liquid
endothermic.
or
endo ma'am.
to,
Endothermic. Endo.
so it's okay, it's endothermic. Now, if heat is released or it's in the product side, okay, release, di ba, release, it's in the product, then that's exo, and endo if it is used as a reactant
Absorb.
or it is absorbed. Okay, so then delta H is greater than 0. Okay, then we also have another one which is calorimetry, which is Q is equal to C, which is the specific heat capacity, then the mass, and then we have the delta T, or in if we have of if we're talking here about the temperature. Now, enthalpy is if we have the volume, if we have the volume at constant pressure. Here in calorimetry is if we have temperature, if we have the change in temperature. So the formula is Q is equal to C times delta T. Now, C here is the specific heat capacity for water. Example, for water, the specific heat capacity of your water is we have 4.184 joules per gram degree Celsius, which means that in order, if you have 25 degrees Celsius of water, and then you want to raise it to 26 degrees Celsius, then you need this amount of heat, which is 4.184 joules. So it means that its specific heat capacity is heat needed is the heat needed to increase or to raise the temperature of your water in a factor of 1. So we have this one. If we have 25, again, if we have 25 degrees Celsius, then you want to raise it to 26 degrees Celsius, then you need this kind of heat. Now, if we have, okay, all right, so I want you to if you were going to calculate the heat, is it the heat for when you raise your water temperature from 50 to 95 degrees Celsius. So how do we calculate that one? Okay, we will have C times mass, and then we have your delta T. So again, the mass here, this one is for 1 gram, okay ha? When you have 1 gram of water, okay, 1 gram of water, when you raise it to a temperature to 1 degree Celsius, so that's for 1 gram. That is 4.184 joules. Now, what if we have 50, we have 35 now, 35 grams of water. Now, what is the amount needed of and heat needed or to lose or to gain in order for your 35 grams of water from 50 degrees Celsius to raise into 95 degrees Celsius para muinit siya. Pila ang heat needed. So we will multiply, we will use this formula, which is 4.184 joules per gram degrees Celsius times the mass, which is
35 grams.
times delta T. What is delta
45
T?
degrees Celsius.
45. Okay, 45 degree Celsius. So Q is equal to pila. Pila ni siya? Q is okay. The signs, we can cancel grams. Here, grams. Then degrees Celsius, we can also cancel degrees Celsius. So we will be left with joules. Now, heat needed to raise 50 grams of water to 95 degrees Celsius is 4.184 times 35 times 45. So that is
6,589.8.
6,500 joules. Now, what about if I ask you in calories?
Convert
Convert
joule
it into
to
calories.
calorie.
So 6,589. Ipas na lang. So, unsa man to? We have
6.58.
okay, 6.58. That's kilojoules to na yan. so Q is 6,500, 5898, ito na, 6,589 joules. Now, this is in joules. We want to convert it into calories. 1, pila to? 101, man to no? 101.3. Liter atmosphere dito. Okay, so we have 4.184. Okay, so we have, if we have 589, 518, 6,589.8 joules times in 4.184 joules, we have 1 calories. So we have Q,
1,575.
so divided by 4.184. Okay, calories. So we have this amount. So it means that it na for the water to raise parmuin siya, for your 50 grams of water to parmuin it to increase its temperature, then it needs 1,575 calories of heat to be absorbed, or 6,589.8 joules of energy. Okay, or heat, because we're talking about here heat. Okay. So that's for calorimetry. Q is equal to C times M times delta T. So again, there will be different specific heat capacity your for your compounds, or different substance, then different specific heat capacity. Okay, so this is for water. We have 4.184. Now, if we have an aluminum, graphite, then we will have different specific heat capacity. Again, specific heat capacity is your C here. This one, C. Okay. Specific heat capacity of a substance is the quantity of heat required to change the temperature of 1 gram of it into of the substance by 1 Kelvin. Okay, so you will increase the temperature. Okay, we have this problem. All right, now let's answer this one. A layer of copper welded to the bottom of Kilojoules weighs 125 grams. How much heat is needed to raise the temperature of the copper? Okay, so we have Q is equal to MC delta T. So what is the M? $125 grams times, what about the C? So it's a copper. Okay, so a copper. Now let's look. Now let's visit Lobach. Copper. Specific heat capacity is pila specific heat capacity sa copper.
Point 79.
3.387. 0.387. Okay, so
125.
point, so 120. 0.387 joules per grams Kelvin. So it's in Kelvin, not in Celsius. Kelvin day class. Okay. We have that one. And then, what about the temperature? It's from 25 degrees Celsius to 300 degrees Celsius. Now, because it's Kelvin, it's not Celsius. Okay, it is siya Celsius, so it's in Kelvin. Now, we will have to convert degree Celsius to degree to Kelvin. So, we have, if we have, pila to? If we have 25 degrees Celsius to Kelvin, so how do we do that? Degrees Celsius to Kelvin, pila? Saan na to?
Um, three question, ma'am?
Okay. How do we
Wala.
convert degrees Celsius to Kelvin?
Plus 273.5.
Okay, so we will add 273.5. Now, we have that
Big-
one. So we have this one from 25 degrees Celsius to 300 degrees Celsius. So that's T1. The initial
And
temperature
final.
is 25 degrees Celsius, and then the T2 is 300 degrees Celsius. So delta T is equal to ilang delta
300,
T?
325.
So,
Ay,
okay, so we
minus mo rin.
275 degrees Celsius. Now, let's convert 275 degrees Celsius to Kelvin because it's in Kelvin. Specific heat capacity is in Kelvin. Now, we will convert that to 1. So, we have 275 degrees Celsius times. How do we convert degrees Celsius to Kelvin?
Plus 275.
3.273.5.
Ay, 73.
Sige, sa man siya sakto. Pwede rin.
Ay, mag-add og 273.5. Ay, pwede pa pananog sa decimal niya.
Pwede. Kailangan i-plus.
273.5, ma'am.
273.15.
Okay, so we have that one, 273.15. So, pila siya?
548.15.
So, we will have 548.15 Kelvin. Okay, so we will add, butang to siya sa pikas. Times 548. 548.15 Kelvin. So we have pila siya. So the amount of heat needed is
Dako kaayo, ma'am. 26. Ay, correct pa.
26,516.76.
in kilojoules. We have 125 times 548. 15. 1, 2, sige, 1, 2, 3, 4. So that is 2.65 times 10 to the 4 joules. So this is the amount of heat needed for your copper to raise from 25 degrees Celsius to 300 degrees Celsius. Okay. Great. So itong definition.
Bilis. Good smell na. Tap na ka? What in your hair? Nothing.
Okay, now let's go to Hess's law. Okay, so we have, all right, we have this one, the Hess's law. Hess's law states that the enthalpy change of an overall process is the sum of the enthalpy changes. So take note of this. Take note of this. It's the sum of the enthalpy changes of its individual steps. So we will be dealing with here the reaction mechanism. If we will go back to kinetics, we talked about reaction mechanism. So the energy, remember, example, if we have okay, here, example, if we have A plus B, so that's step 1, then it will form into C. Okay. And then C, for the step 2, we have C plus D, then it will form an E product. Okay, so for the reaction to proceed, diba, it needs an energy. That's why we have catalyst, diba? It lowers activation energy. Now, the energy here needed, or the heat needed, delta H is equal to H, not delta, it's not the two. Okay, so H is equal to, example, if it needs 300 joules for step 1 to proceed. Now also step 2 needs H is equal to H reaction. Okay. H reaction. Now this needs about 600 joules. Now we have that one. So unsa product ani? So again, tagay daw kong equation, final equation ani overall equation. If we have reaction 1 and reaction 2, step 1, step 2. Write the overall reaction. Wala, nalimot na. Okay, cancel. So we have A plus B plus
B is equal to A.
D, then it will yield E. E. So in Hess's law, it states that the sum of energy needed uh, to produce this overall reaction is the sum of the initial energies. So what we will do, the final delta H here is equal to Diba, some Ramanistra, so we have 900 joules. So this is Hess's law. So this is the enthalpy, okay, the enthalpy, the total enthalpy for this reaction to proceed. So it's the sum of your step by step reactions. So we have that one. Okay, that's Hess's law. Okay, let's have calculating delta H for an overall processes. Identify the target. Okay, add. Okay, so we have that one. All right. Now, if I have, okay, so what will happen? Okay, so this one, example, if I have A plus B, which yield to C, then the H reaction is equal to 300. No? Then what is, okay, what is 1/2 A plus 1/2 B to C, 1/2 C? What will be the H? What will be the enthalpy? Enthalpy is,
Half pod, ma'am.
okay, so we will divide this one. So enthalpy is 150 joules. Okay, what if I have 2C, then it yields 2A plus 2B. What will be the H, the enthalpy?
Negative 600, ma'am. Sige.
Okay, do you agree? Do you agree, Emma?
Nga, parang di man ka.
Unsa to, Emma?
Dili ako nga, kuan.
Dili ka ma-agree?
Ay, dili mo agree ka na. Dili mo, kay ko kakuan sa question mo.
Okay, do you agree that the enthalpy of this reaction, first, second, third, okay, that the enthalpy of the third reaction is 600 joules. Do you agree? Oh, negative 600 joules.
Yes, ma'am.
Why?
Great.
Now, going back in number two, it's the same reaction. It's the same reaction. It's reactant A and B, then it yields C. Now, what happened there is just the what happened there is the amount. Okay, the amount of A needed is 1/2. Okay, so 1/2 of A, then 1/2 of B, and then 1/2 of C. So that's why if it's 1/2, then the enthalpy needed will be a half also. So that's why we have the enthalpy of number 2 is 150 joules. Now in letter C, we have this one. If you compare, okay, you compare number 1 and number 3 reaction, what happened? What happened to
Probably, ma'am.
so there is a reverse reaction. Now, if a reverse reaction, so the the enthalpy also will be reversed. So from the surrounding, or from the system to the surrounding, we'll have surrounding to system. So we will have negative also because it's reverse. Then what about uh the atoms? Okay, we have two. Now we have two. So we will multiply the enthalpy of by 2. So that's why enthalpy is equal to 600 joules. So that is Hess's law. Now let's go if this one. Okay, two gaseous. Okay, please read. We have Mona Lisa. Ungkol.
Yes, ma'am. So two gaseous pollutants that form in auto exhaust are carbon dioxide and NO. Environmental chemists is studying ways to convert them to less harmful gases through the following reaction.
Okay, so we have Christian. Okay. Sabuhatan natin eh. Okay, so this is your overall. Okay, this will be your overall reaction. CO plus NO, then we have CO2, and then half of N2. Let's write that one. Ooh. Okay, we have CO, carbon monoxide plus NO. Then it yields to CO2 and then one half of N2. Okay. So we have that one. Now we are going to calculate delta enthalpy. So we know this is an overall reaction. So this overall reaction came from the reaction pathway of step 1 and then we have step 2. Step 1 there is CO plus 1 half O2, CO plus 1 half O2. Now it yields CO2. We have CO2. Now delta H or the H, okay, delta H of reaction 1 is equal to pila ka joules? Negative 283. Negative 283 joules. The number 2 is N2 plus O2. 180.6. Okay, so we have this one, the reaction 1 and the reaction 2, in order for us to have this overall reaction. Now, okay, so this one, so, kasi buhato na to in order to get this product. We have CO plus NO. We have CO2 plus 1 half N2. So, unsa itong buhaton in order for us to get this product? We have CO. Okay, CO na siya sa reactant side. Then, we have CO2. Napot siya sa product side. Okay, good na siya. Then, the O2. Okay, O2, wala ang O2. It's okay. So, we will, now the NO is in the reactant side for the overall reaction. Mo man itong overall reaction, overall. NO is in the reactant side. However, in reaction mechanism step 2, NO is on the product side. Now, unsa itong buhaton? Per mahimo siyang ang itong NO maabot sa product side. We will
Reverse, ma'am.
Okay, so we will reverse this one. So we will have number 2. Okay, ato siyang balihon, no? So we will have 2 NO. Then we will have N2. Then we have plus O2. Then what will happen to your reaction will be reversed, will be negative also. Now, will that be enough? Okay. So if we have that one, okay, na. Okay, will that be enough for us to get this product? So, mahimo siyang 2NO. Now, let's ano daw? CO2. Ano sa patong buhatan to achieve this product?
Kuan ma'am, i-factor out ang 2 ma'am.
If factor out ang 2,
Yes ma'am.
this one will be 1/2, no? 1/2 man ni siya, no?
Yes
Okay.
ma'am.
So we will multiply. We will
Multiply both by 1/2.
both by 1/2. Okay. All right. Very good. So we will multiply number 2. We will multiply number 2 with 1/2. So factor out 2. We'll factor out ang 2, and then also 1/2 will be 1/4. Pizza.
Dili mo na siya kuan ma'am, 1/2 daan ma'am. O2 ra na siya.
Ay, sorry. Sakto di ni 1/2. Okay. So we have, all right. So what will happen is we will have, okay, number 1, CO plus 1/2 O2, 1/2 O2. Then this yields CO2. For number 2, we have number 2. The final reaction for number 2 is NO. Then we will have 2 O2. So multiply it with 1/2. So we will have 1/2 O2 plus 1/2 N2. Okay. So we will now sum. So the sum will be, okay, cancel O2, 1/2 cancel. So the overall reaction will be CO plus NO. Then we will yield CO plus 1/2 N2. Okay. So we now have achieved the overall reaction, which is already given. So nakuha na nato. Then what about the reaction for number 2? What about the enthalpy? Because we have reversed it, the enthalpy, it will become negative. So delta H reaction number 2 will be negative 180.6. Now, we multiply it by 1/2. So, 1/2 po siya. Then, what will be the H reaction? Will be
negative 90.3.
Negative 90.3. 90.3. Okay, we have that one, negative 90.3. So, we have this one, delta H is equal to 283. Negative, no? 283.0 joules. Then delta H for number 2 is equal to negative 90.3. So what will be the enthalpy, heat enthalpy for this one, for the overall reaction? So it will be just the sum. So delta H overall, okay, is equal to ila negative
Negative
373.3.
373.3.
73 joules. So this will be your this will be your final or overall heat enthalpy needed to release. So, kung ano lang no, kung dahil ang uban ko. Okay. So, whatever you do to reaction, either you multiply it by 2, so you will, the heat enthalpy will also be multiplied. Then if you reverse, then you will, no, reverse put the value. If it's positive, then it will become negative. That's Hess's law. Okay, so we have oh, all right. We have the same answer. Okay, now we're done. Okay, so that's all for today. We're done. Pang has Laura tataman. Then let's go to the second law of thermodynamics next meeting. So that's all for today. You just review na lang. I'll give the PowerPoint. Ako mo siyang gi-download.
Then magpasan po mi sa recorded, ma'am, ha. Thank you.
Okay, no problem. So we
Okay,
have
ma'am.
that one. It's very easier to show. Just take note lang if the system or the surrounding ba. Okay. And then enthalpy is if we have the enthalpy is if we have if we have constant pressure, and then we have the change in volume, and then you can use the Q equals mc delta T if you have the change of temperature. Okay, so you have formulas to familiarize. So number one is delta E. Delta E is equal to Q plus W. Then we also have W is equal to negative P delta V. So, or we can write that one delta E is equal to Q plus or minus P delta V. Then we also have okay. Then we also have for calorimetry, Q is equal to MCAT, mass, specific heat, and then your delta T also. Then for Hess's law, so you just you add. Okay, for then you take note of who absorbs and who released. Is it the surrounding or the system? Oh, dapat should mo because in physics we also have delta E is equal to Q minus W. In chemistry we have delta E is equal to Q plus W. So they are the same physics. Okay, so they are the same. However, it's they have different point of view. They have different point of view because in chemistry we will look at the system. Okay, we'll look at the system we look at the system being the system. Okay, gibuhatan siya. Okay, we look at the surrounding doing the work. Now here in physics, we look at the system doing the work. So mo na the same merchant siya, but here it's the system. And here it's the surrounding. A different point of view. Different point of view. But okay, in chemistry, we will use this one always. Delta E is equal to Q plus W. We will use this one. Okay, so naabot na mo ani sa inyong physics.
Wala pa, ma'am.
Wala pa ma'am.
Pero namoy physics. Namoy physics.
Na, ma'am.
Ah, ma'am.
What's na yung topic?
Sa buoyancy na, ma'am.
Buoyancy.
Science. Okay. Si Sir Ralph yapon, no?
Yes ma'am.
Yes, ma'am.
Yes, ma'am.
Right. So, we have that. Hapit na mo, Muhammad.
Ambot lang, ma'am.
Ambot lang, ma'am, kay siya rin na ibalo kung siya mo stop. Wala may kabalo sa iyong kuan.
Okay. So, this one, ano na siya? Then, after this one, we will, electrochem na ta. We will touch a little of second law of thermodynamics. Again, the first law is, so that's the first law?
Energy is cannot be created nor destroyed.
Perfect. Okay. So, yun na siya. Now, in the second law is, di ba, the same amount. Okay. So, if you have an engine, if you have a car, for the second law, if you have a car, okay, so the engine will do the work. Okay. So, if we have 100 joules, now 20% of it, 20%, so meaning 20 joules rapid, no? Okay, meaning, so if you have 100 joules of energy or heat, only 20 joules will be used to move the car. Okay. The other will be transformed into other forms. Okay, so only the 20 joules. So, gamay ra kay siya if you have a heater. Okay, if you lose 100 joules, then you recharge, kinahanglan nimong mag-recharge, pila mo idugang para mabalik sa iyang 100 joules. Diba, o sa first law, 100 joules po siya. However, in the second law, if 100 joules ang nawala, then you will add more. You will add, magkinahanglan kag mag-recharge o more than 100 joules. Because, sa imo again, like this one, sa imong car, only 20 joules sa gali na kuha na to move the car. Because we have what we call heat magtapod like our money, like naatay paliton sa atong 20 pesos nga coffee, mao na atong gibayaran. However, sa tinud-anay, dili kaabot og 20 pesos imuhang coffee because you have the tax. Now, just like here sa second law, we have also what we call the heat tax. Na imong gikuha nga 100 joules, dili nimo na bayaran og 100 joules ra, but more because naay mga heat tax, heat na dissipated to other forms or dissipated to other places. We call that one heat tax. Like para sa ato natay tax, just like the heat, napod sila tax. Okay. Okay, so you have in first law, you can't win. Okay, you can't win. You can't win. Now, di mo ma-form, di po ka maka-destroy because you can't win. Now, in second law, you can't break even. You can't break even because kung unsa nawala, you have to recharge more. Okay, because we have what we call the heat tax. Okay, this is the first law and then that is the second law. Okay, so that's all for today. I hope na pud mo
Right.
na learn. Okay, so just study and just review na lang po. Okay, then after this one, we will have electrochem, then finals na dayon. Last na. Last na ni ay kani then humana na magud ni. Kay marag gamay na lang kahit yung isa. Then ang kuan na dayon electro. So after that one, we're done. Finals na dayon ta. Electrochemistry. So in
Excuse me, ma'am.
electrochemistry, we will talk about cations, anions, inana. We do yes.
Idungan rin nimo ang exam sa katong una ma'am tapos sa electro
Oo.
or mag-exam ta karong
Dili, ang di ba nga atong first atong exam karon Friday is acids and bases. Then we will have also the katong ionic na part but it's still part of acids and bases man gyapon to. So the acid, the buffer, and then your titration. So dungan sila. Then this time, kaniog ang next. Maura na dayon, finals. 13 nga lita kay next ano na pagka Wednesday mag electrochem na ta. Murag mahuman na nato ni siya karon na week.
so Friday ang kuan ma'am ang kuan exam jud final.
Oo. Final. Dili pa. Pre-finals. Ay, unsa man. Gusto
I
ninyo
mean
ka
sa
na
kana katubang nga topic.
kaning karon?
Ang last daw, ma'am.
Di ma'am katong acid base.
Oh. Oh, kato Friday. Sa karon is ano pa,
Okay, ma'am.
mga 13.
Okay, ma'am.
Mga 13 na lino. 13 or 10. Then we're done. So
13 lang,
that's
ma'am.
all. Ha?
13 lang pag-exam.
Okay. Oh, that's finals naman. 13. Diyon. Alright to. That's all for today. Thank you so much. Kimagdungan pa ko. Bye-bye.
Yes, ma'am. Bye-bye, ma'am. Bye, ma'am.
Okay,
Bye,
ma'am.
ma'am.
Bye, ma'am.
Oh, you can't win. You can't win and you can't break even. Oh, that's all. Bye-bye. Thank you so much.
Ma'am, bye.
Goodbye, ma'am. Thank you.
Bye, ma'am.
Dapat siya pahabol si ma'am mo eh.